Hi everyone, welcome back. Today we are going to see about the EMF equation of single phase transformer. So in a transformer, the source of AC is applied to the primary winding. So due to this, the current in the primary winding, that is called magnetizing current, it produces alternating flux in the transformer core. This alternating flux gets linked with the secondary winding through this transformer core. Because of this phenomena, mutual induction and EMF gets induced in the secondary winding. The magnitude of this induced EMF can be found using the following EMF equation of the transformer. So here the primary winding is connected with the source and the secondary winding is connected with the load. Here the V1 is nothing but primary voltage, I1 is nothing but primary current, E1 induced EMF in the primary winding, N1 number of turns in the primary. And V2 is nothing but secondary voltage, I2 is nothing but secondary current, E2 is nothing but the induced EMF in the secondary, and N2 is nothing but number of turns in the secondary, and pi is nothing but the flux linkage, flux. So here this is the flux waveform. So here with respect to the flux and with respect to the angular velocity omega t. So here the produced flux is maximum at the time of t by 4. At the time of t by 4, that is nothing but t is equal to 1 by f. So this is denoted by t is equal to 1 by 4, t is nothing but 1 by 4 f. Okay, so here the maximum flux is at the time of t by 4. So we know the frequency and the time is both are inversely proportional. So instead of t, v is equal to 1 by f. So therefore pi m is equal to t by 4. Instead of t by 4, we are rewritten as 1 by 4 f. So 1 by 4 f is taken into the numerator. So 4 f into pi m. So now the induced EMF per turn, which is equal to the rate of change of flux per turn. So that is 4f pi m. So we know that the form factor is equal to our RMS value divided by average value. So this value which is equal to 1.11. So therefore, the average value or the RMS value of the EMF per turn, which is equal to 1.11 into 4f pi m. So which is equal to 4.44 f pi m. So the RMS value of induced EMF in all primary winding, okay, now in the primary winding. So the above equation 4.44 f pi m, which with represent for a single turn. If the turns having it more than 2, 3, 4, 5, or it may be 10, 20, 30, whatever it may be. So based on the number of winding in the primary section, so the induced EMF in the primary winding, which is nothing but E1, which is equal to 4.44 f pi m into N1. So here the N1, it indicates the number of turns in the primary winding. So similarly, the RMS induced EMF in the secondary winding can be has the E2. E2 is nothing but the induced EMF in the secondary winding, which is equal to 4.44 f into pi m, and with the N2. The N2, it represents the number of turns in the secondary winding. So based on this equation E1 and E2, so this much amount of voltage will be induced in the transformer. So the induced voltage in a transformer is mainly depends on the number of turns. If the number of turns get changeable, the induced voltage also gets changed. So here the frequency is always constant, and as well as the magnetic flux density, it may be changed according to the supplied current and as well as the type of material, etc. Okay. So the voltage transformation ratio. So here from the EMF equation of the transformer E1 and E2, here K is nothing but in transformation ratio. Here if the number of turns is greater than N1, here the transformation ratio K is greater than 1. So this is called a step-up transformer. If the number of turns in the secondary N2 is less than N1, so the K is also less than 1. So this is nothing but a step-down transformer. So this is an assessment. If the input of transformer is square wave, the output will be same square wave or pulsated wave or triangular wave or sine wave. So what will be the output of the transformer when the input is square wave? Okay, la. So put your answer in the comment section, and these are the few references for single phase transformer. Thank you.